Solving a system of equations using substitution is a little different than using graphing. Obviously, graphing, you're going to have to graph whatever it is you're solving. When we're solving with substitution, however, we won't have to graph it. We're going to solve it by substituting values so that we can get one variable alone and solve for it. It's got a couple steps to it. The first of which being we've got to solve one of the equations for either x or y. So you want to get it in terms of whichever variable is going to be the easiest to solve for. In this case, it's going to be easiest to solve for my y equals. In order to get this to be a y equals on just the bottom equation, I can subtract 2x from both sides. If I subtract 2x from both sides, I'm going to be left with the equation y equals 9 minus 2x. Right, so that's simple enough, but it is the first step. First step we got to do is isolate one of our variables. We isolated y. The second step now that we have it isolated, and let's bring our original equation down as well. So we had 3y minus 2x equals 11. So we've got 3y minus 2x equals 11. Okay, the next step now is to take what we just solved for y and plug it in for y in the new equation. So this is y, 9 minus 2x. We're going to plug it in for y here in this equation. So we're going to rewrite this equation as 3 times y, which is 9 minus 2x. Then we're going to write the rest of the equation. Minus 2x equals 11. Now we can distribute 3 times 9 is 27. 3 times negative 2x is negative 6x. I've got the rest of my equation still. Negative 2x will be here, and I've got an 11. Now I'm going to continue by solving this like I would solve any other equation. I've got 27 minus 8x equals 11. If I subtract 27 from both sides, I would have 11 minus 27 would give me negative 6. So I'll have negative 8x equals negative 16. Then I can solve for x by dividing by negative 8 on both sides. So if I go about doing this substitution here, I can solve for x here, and I will have x equals negative 16 divided by negative 8 is going to give me a 2. So our third step would be to go through there and solve for x. Now if I have x equals 2, I want to go back into the original equation I had. And if you think about it, I had y equals 9 minus 2x, which is going to be the easier one to work with. I'm going to plug in 2 for my x here, so I'll have y equals 9 minus 2 times 2, which is going to give me 9 minus 4, which will give me a 5 for my y value. So if I got x should be equal to 2 and y equals 5, what I can do now is I can look right back at my original equation, which was 3y minus 2x equals 11. So let's write that down. 3y minus 2x equals 11. If I plug in my x and my y values to check this, I'll plug in 2 for x, 5 for y. I will get 3 times 5 minus 2 times 2 equals 11. 15 minus 4 equals 11. I'll get a true statement here. 11 equals 11. So I know if I plug them into the first original equation, I've got a true statement. The next one I can check as well. Y plus 2x equals 9, and we can see if that's going to work for us. So y plus 2x equals 9. Y plus 2x equals 9. If I plug in 2 for x, 5 for y, that'll give me 5 plus 2 times 2 equals 9. 5 plus 4 equals 9. 9 equals 9. Bingo. I've got an accurate statement. My solution would be 2, 5. So that's my x value and my y value. And remember, just like when we were graphing, to find a solution to these equations, it's going to be where the two lines intersect. And so that intersection point would be at x of 2, y of 5. And then we'll work through one more example. If I've got x plus y equals 5, and 2x plus 3y equals 5, and I want to find the solution to those. So I want to find when those two equations are equal to each other. First thing I got to do is solve for one of my variables. In this case, I'm just going to solve for x. So I'm going to get x alone. To get x alone, I'm going to subtract y from both sides, which will leave me with x equals 5 minus y. I'm going to plug this 5 minus y in for x in my second equation. So I now have 2 times 5 minus y plus 3y equals 5. And all I did was substitute that value of x. So if I do my distribution, I'll get 10 minus 2y plus 3y equals 5. If I combine my like terms here, I'll get 10 plus y equals 5. I subtract 10 from both sides, I'll get y is equal to negative 5. Now the nice thing about it is up here I already solved for what x is going to be. X is going to be 5 minus y. If I solve y here, got to be careful with my signs. X equals 5 minus negative 5. Anytime I'm subtracting a negative, it's just like I'm adding. X equals 5 plus 5, or 10. And it's always best practice, once we have solved, it'll always be best practice just to write these out. So we write it in x, y form, just like it's a coordinate, because that is where they intersect. I'll write it as 10, negative 5. That's going to be my answer. So all I did was substitute in one of my variables, solve for the variable, and then substitute that variable right back in to solve.